asphalt, 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 asphalt. Here, the laboratory technician measures the height of the blocks. He takes 4 separate measurements at equally spaced intervals. These values will be used to correct for stability later on.
Yeah. And then once we've done that, we take it over to the way it dries. Put it on the scales and weigh it. So you put the weight down here.
Here, the laboratory technician performs the bulk specific gravity test. He starts off by weighing the sample in air and then placing it in a 25-degree water bath for 3 to 5 minutes. He then weighs the sample in water. The buoyant force exhibited on the sample is equal to the weight of the water displaced. The volume of the water displaced is equal to the volume of the sample. This allows a density or a specific gravity to be calculated.
Write that down, that's weight in water. And we take it out. We take it out.
The technician then dries the sample with a damp towel to get it to what is known as saturated surface dry. The sample is then weighed again, and this figure is also used in the calculation.
Scales, and that's SSD 23.5, which means this one has not got a lot of air voids.
Now we perform the theoretical maximum specific gravity test. First, the sample is weighed. This sample is dry.
What temperature do you want it at the end of the test, Steve?
Water is then added to the flask. The technician tells a funny joke.
25 degrees plus or minus 1.
Yeah.
A little more.
Should do.
The sample should be completely covered with water.
So then you put it in here. Fill it up.
The flask is secured to the vibrating table.
It's a long hose.
A hose that is linked to a vacuum pump is attached.
Right. And it's supposed to have safety glasses and gloves on. You put on your vacuum in case it...
Remembering safety, the technician fetches a face shield and gloves.
15 minutes, eh?
Yep.
Right, so turn the vacuum and the shaker on.
Implosion is always a risk with this test.
Do it slowly.
The technician then applies vacuum and turns on the vibrating table.
Venting there. Turn that round. Get that going for 15 minutes. So you see the timer.
As you can see, air is escaping from the sample.
Right, so this one's had its 15 minutes.
After 15 minutes, the flask is removed from vacuum and removed from the vibrating table. The technician pretends to drink the flask. The flask is placed in 25 degrees Celsius water for 10 minutes.
Kelvin.
This allows the flask, sample and water to come to a temperature of 25 degrees Celsius.
This is one I prepared earlier.
The technician carefully fills the rest of the flask with water. This water is also at 25 degrees Celsius. He must be careful so as not to introduce any air into the sample at this point. A glass plate is then slid over the top of the flask. This ensures the flask has a known volume.
Like a champ.
Here and there. And you hold it down.
The outside of the flask is dried off.
Get all the excess water off.
The flask and contents is then weighed.
Done.
The final test in the Marshall mix design process is the stability and flow test. The same compactor specimens from before are heated at 60 degrees Celsius for 30 minutes. They are then placed in a circular jig and crushed. The rate of crushing is 50.8 millimeters per minute. that was a good one.
So it didn't flow much.
Oh, it just looked good on the video.
Alright.
The peak resistance load gives you the Marshall stability. We use our height measurements from earlier to correct the stability measurements.
Alright.
Sweet. So we'll get the results.
Oh.